to ping it all the time. Let's look down. Have a source. I draw a picture to explain. When we talk about experiments in the future, we'll talk about the loopback interface, called loopback. When we do experiments and work on projects in the future, the source command is often used. A device on the left. A device on the right. Now the devices need to ping each other. There is a direct address between the two of them. Like how much? The one on the left is 1.1.1.1. The one on the right is 1.1.1.2. Because they are directly connected. So you can directly. But if on the left side this device here, loopback. For example, this loopback address is 2.2.2.2. The device on the left can directly ping 1.1.1.2. Because it defaults to this outgoing interface to send messages. If the reply packet, the destination IP is the left device. The device on the right also knows how to get to the device on the left. The two of them can pass. That is, if no source is specified, it is the outbound interface. If source is specified, equivalent to now, it is from the address 2.2.2.2 of the left device. Go to the right device. Data can pass. Because when the data is sent, check the route on this device. But when replying to the packet, for the device on the right, it is not replying to 1.1. 1.1. It is replying to 2.2.2.2. It does not have the address of 2.2. Then it can't come back. Where are loopback addresses often used? Used to simulate a network segment behind this device. One of my devices on this device returns configured at 2.2.2.2. It is equivalent to connecting a device behind this device. This device is 2.2.2.2. Here is 2.2.2.1. I'm on this device with 2.2.2.2 as source to ping this 1.1.1.2. Now the two network segments can communicate. That is, you can go directly to ping 1.1.1.2 now. You use 2.2.2.2 as source. It may not be possible to ping 1.1.1.2. If it doesn't have a route, it won't work. When we go to learn routing later, often originates from an address to ping another address to ensure that the routing configuration is correct. Less likely to be involved in NA. In NP, you will often come into contact with. Let's move on to the last thing. Traceroute. This can see what happened to the equipment along the way. There is also a source in traceroute that can be specified. There is nothing special to pay attention to. I will give you a simple demonstration. Still take PC as an example. I will give it a trace route first. Add a dir. Don't worry about this. I don't want it to go to domain name resolution. For example, I give it 4114. Let's test it. It is the same as ping. They are all encapsulated with ICMP packets. But you will find there are many symbols in the middle. We wait patiently. Usually use this command. You will find some places can go. Can't reach some places. That is to say, I will go to such an address in the future. Public network addresses along the way. We all know the domain name resolution server is actually a public network service. I have now visited an address. This is a public address. Along the way, you have to go through a lot of devices. On the public network are public addresses. What I want to know is my PC accesses to the public network. Another time when the service was finally docked. Who are these devices in the middle? We will use traceroute. Here you will find There are a lot of things we can't catch. Many are symbols. For the current overall equipment, it will have a security feature. We now talk about its mechanism as a whole. Why it can track so many devices. I give an example. I draw a corresponding environment. I am drawing 5 routers now. Device 1 is 2.2.2.2. Go to access device 5. Device 5 is 1.1.1.1. When I visit, how does traceroute retrieve each device? This is called traceroute. It is based on the TTL, and the entire IP packet is carried out. I said TTL when I talked about the message before. TTL is time to leave. Where does this message go? You can't forward it down. If a message is received now is 0. TTL value is 0. The packet will be discarded directly. Device 1 sends a message to 1.1.1.1. That is, from 2.2.2.2 to 1.1.1.1. First a message is sent. In this message, TTL is equal to 1. This proves that this message can be sent once below. Now after device 2 receives the message, the local will subtract 0 from this one. Becomes 0. Once this message becomes 0, it can no longer be sent down. It is equivalent to the termination of this message to device 2. Can't send it down anymore. So now device 2 will return a TTL timeout to the source. This means device 2 will use the address of this interface to reply to device 1. Device 1 receives the message and knows it is this interface. It knows who its next device interface is. Next we will send a new message. In the new message, TTL is equal to 2. The message is here. TTL minus 1 equal to 1. Can continue to send down. Post here. After receiving device 3. TTL minus 1 again. Minus 1. Reduced to 0. Once equal to 0 here. It proves that the data cannot be sent down. Now tell device 1. TTL timed out. The packet of device 1 did not arrive at 1.1.1.1. So device 3 will also use its interface. Send a message to device 1. Device 1 gets the address of device 3. Next, TTL is equal to 3. Arrived at device 4 here. Device 4 will now also reply with a packet to device 1. After device 1 gets the address of device 4. Then go on down to device 5. This is the destination. The message is also over. But device 5 will also reply to device 1. Device 1 knows that it has arrived. So it is equivalent to in this process. TTL keeps increasing. Cause the packet to arrive at a new device whenever. They all have to reply to device 1. With a timeout message. Then use this as a means. Get the IP address of each interface. So device 1 knows which device it has passed through. According to us, we should be able to get other equipment. Why do symbols exist? Because some equipment along the way is invisible. That is to say, a detection based on TTL value timeout may cause the address of the device to be exposed. That is, IP addresses of devices along the route will be exposed. Please pay attention. On our website,